Our first speakers for today would be speaking on a living legend, Engineer Mahendra Raj. With a portfolio of over 250 projects and a career spanning nearly 6 decades, there's no simple explanation for who Raj works with or how he works with them. Each project displays a different facet of how he works with architects. So today we have architect Rohit Raj and his wife, architect Vandini Mehta, who would be sharing their experiences with the master. Architect Rohit Raj graduated from the School of Architecture, Ahmedabad, CEPT, with a distinction in his thesis and received a Master's of Science in Architecture Studies, degree in Architecture and Urbanism from MIT 2002. His professional work experiences include an initial training in India from Arcop Associates and Sachdev Eggleston Associates in Delhi, and Balakrishna Doshi in Ahmedabad. His international exposure started with CA Ventin Associates, Toronto, and Fry Otto's Institute for Lightweight Structure in Stuttgart. He went on to work for 5 years in New York City with Davis Brody Bond and Elizabeth Kennedy Landscape Architects. In DBB, he worked on very prestigious projects, namely the World Trade Center Memorial, New York, and Nicholas Grimshaw's Experimental Media and Performance Arts Center in RPI, Troy, New York State. While with Elizabeth Kennedy, he worked on a project. He worked as a project architect and design consultant on the Harlem Stage Gate House project and an interpretive landscape project at the site of the first free African American quarters in Vicksville. While in America, he was invited to studio juries in MIT, NJIT, and Pratt. Since fall 2007, he has taught in Urban Design Program of SPA, New Delhi, and is currently a visiting faculty at Sushant School of Architecture. His academic research interests in the domain of visual urban representations and politics of urban development and have led to a photographic exhibition called Placed Settings in New York. And he currently works with his wife, architect Vandini Mehta. The next speaker, they are going to do a joint presentation. So she received her undergraduate degree from School of Architecture, CEPT, and an MS in Architecture from University of California, Berkeley, USA, with a specialization in environmental design in developing countries. She was awarded the Department Block Grant for all 3 semesters at Berkeley and served as a teaching and research assistant at the university. She also spent a semester at RMIT Melbourne, Australia on an exchange study. Her academic and research interests include investigations of urban histories and geographies, as revealed in the current neoliberal times, film and space, especially of current Bollywood cinema, and also spatial issues dealing with Indian rural development sector. She has presented her work in different international conferences and is currently a visiting faculty in the Urban Design Program of SPA. Her professional practice included non-profit community-based planning and architectural work with Seva Mandir at Udaipur. As an architect and design consultant, she designed a block office, community center in Kotra, a village community center using participatory design method and local eco-friendly materials, and a showroom for handicrafts. Besides this, she was involved in a few research and writing projects, and finally in heading a funding initiative with Poonam Abbi called Friends of Seva Mandir, New York. She is currently a member in Executive Council of Seva Mandir. During 5 years in New York, she gained experience in high-end residential architectural work and some office and gallery renovations at McBride and Associates Architects, along with 2 Tibetan projects, a monastery and a school for Vikram Sila Foundation in India and Nepal. Later, she joined Magnuson Architecture and Planning as a project architect for mixed use and mixed income housing and planning project. During her work at MAP in New York City, her team was awarded 2005 AIA New York Housing Design Award for Melrose Commons, a revitalization plan of an inner city neighborhood in New York. And in 2009, Big Apple Brownfields Award for the Affordable Housing Award category for Parkview Commons, a brownfield redevelopment housing project. She is also an accredited lead professional and led MAP's team proposal of Melrose Commons, which was a qualifying entry for the pilot program of LEAD for neighborhood development. Since 2007, she has started her own consultancy along with architect Rohit Raj. The studio is named as Van Row. May we have a big round of applause for Rohit and Vandini. Request both of them to come on stage.
Good morning. Thank you for having us over. We were requested by the organizing team to get a message from Mr. Raj. So we'll play that first. It's a 1-minute message for everyone here.
That Architects, Engineers, Surveyors Association of Pune is celebrating its 50th anniversary. It's wonderful to have survived for these 50 long years and done productive work. As I understand that your association is very popular and has been very productive in different types of works. I'm very happy that the way you are celebrating this 50th year is by showing works of 4 individuals of different discipline, whom you prefer to call 4 masters. That is your choice. We are showing works of 1 engineer, 1 landscape architect, and 2 architects. You know, all of them, well, except for the engineer, all others are no longer there, but have left the legacy of their works there. And they were personal friends of this engineer, whose work also you are going to see. Well, I don't want to be between you and the proceedings, so I'll say all the best to all of you who are present here, who have come from different parts of India, and the organizers of this conference. My very best to all of you. Bye-bye.
Good morning. Thank you, Ravi, for those very long introductions. But really, and actually, I want to clarify one thing. I am Mr. Mahendra Raj's son, and Vandini is his daughter-in-law. We are not his disciples. We are not engineers. We are architects. We have done, I've been working and living with him for now the last 12 years. And we have done many projects together. But this presentation is really about the work that he's known for. And we are focusing on the first 3 decades of his practice, the 60s, the 70s, and the 80s, when there was a lot of innovation in India in architecture and engineering, where the history of the script of modernity for Indian architecture was written. And it was written by my father, Mahendra Raj, along with all the architects. They all sort of worked together and created sort of a portfolio of works, which I think should be the envy of the world, but it's not there right now. And that's why we choose to show this again and again for that reason. We'll discuss only a few of his projects out of the 250 to choose from, because they all exemplify the idea of structure and the way it sort of enhances, implicates architecture in ways that it could not have if the person, where the engineer in focus, would not have been there. And the underlying narrative for us is this transnational exposure that they all went through. Mr. Raj, Korea, Doshi, Kanvinde, Raje, and the fact remains that they came back to India at a very at a very fertile moment, filled with opportunities that created this abundance that we have, and it's for us to safeguard it because it is disappearing very quickly. With that, I start. We call the presentation the narrative, the structural narrative of Indian modernity, and it inflects and contributes and helps create many artifacts, his works, Mr. Raj's work, that create a narrative of Indian architecture, modernism, post-independence. I start with his years of apprenticeship, where he started in Chandigarh. He joined the PWD in 1946 as a young engineer and then chose Simla post-partition. And he was in, I think, one of the last few trains which left Lahore without being attacked. So he was very lucky with that, and he came to Chandigarh, and he was responsible for the Indo-Tibet Road, and then he came, and he was the first engineer positioned in Chandigarh, and what he was actually doing was collecting raw material for the new site that was being developed. So from there, once Corbusier was selected, there was this whole idea of the fact that the government chose an international architect but was very confident about the engineers of India. Bhakra Nangal Dam had been already done by then or was being constructed. And Corbusier, despite his wish for French engineers, was not given that he was not given the French engineers. He was handed over a team of Indian engineers who actually had no experience in structural design. So when my father took up his first building as a junior engineer, exactly what he was, he was assistant engineer to Gulzar Singh, and he had not even designed a tie or a beam at that point. So this was his first project, and Gulzar Singh gave him a lot of books by which this Gulzar Singh had gone to America and come back. He had the structural codes from America, and they designed this building together. And he he keeps talking about how this experience with these buildings brought him very close to the idea of structural engineering. He took it to like a fish takes to water. And in this building, this was Corbusier's sketch with the canopy, the parasol, and this is what came up as a tie with supported cantilever tie, conoidal shell roof with columns in the middle to support it. So, I mean, there was already shifts that were happening from what the architect was giving to what they were proposing as a team to the master architect, Corbusier. And these are some of the images of Chandigarh. And then he became the executive engineer, the engineer in charge of the secretariat. And here again, there are these stories of him going to Corbusier, because Corbusier had, if you see the bottom left, he had provided the facade of the secretariat, where the space where the governor's office would be, was the place where he broke the facade. But none of the verticals and the were coming below each other. They were all sort of shifting. And Mr. Raj went back to him to say that this is not possible. And he had a sketch with him. He had worked enough at Corbusier by then to know that he had to give him options. And he had a sketch of what may work. And Corbusier got extremely angry with him, but snatched the sketch from him, went back to the office. 2 days later, came back saying that I agree with you, and he sort of modified the elevation to the needs of the engineer, which is there. So this is the final where I'm talking about the bay in the middle, where the whole facade gets broken. So these were the experiences he had, which there is no pointer, no? This was the original facade by Corbusier, which did not have any verticals going down, and that's what came up finally. Post that, he went to New York. He went back, he sort of decided this was his future, engineering. He went and studied in Minnesota and did a higher degree in Columbia and started working for this firm, Aman and Whitney in New York. This firm was one of the leading firms in engineering that time, and they were sort of breaking all grounds there. It's interesting. He joined in the special structures division in Aman and Whitney, an international space of eager young minds. And this is where we believe he understood the idea of structure not as giving solution to the architect, but as structure as an art form itself. Abator, his very close friend and colleague from there, wrote for the book that we wrote, he wrote this passage saying, Boyd Anderson, Andy to us, was a partner in charge of the Special Structures Division. He was an inspired and inspiring engineer. He made us look at structure as a breathing, living, dynamic, moving, and sometimes even mischievous creature. We all got rid of the notion of statics and make it stand up. Our real job was to tame the structure, allow it to move within its limits without affecting its serviceability in the process. It was this nurturing and challenging environment that Raj blossomed, where all his peers as well as the peers in the firm appreciated his engineering skills and people skills. And these two ideas, engineering skills, idea of engineering as an art form, and the people skill that he worked with all these architects. They were young, but architects, as we all know, we come with our share of egos, we come with our share of what we believe is our vision, and to be able to work and manage them and then to create a portfolio of works that span decades, it sort of brings this personality together. This was the quote. So in New York, he worked on the Mohawk Angle, which is a 150 feet balanced cantilever on folded plates. And then he went on to work on a 400 feet diameter dome for the assembly building in Illinois. This was a folded plate structure, and here again in the office he was contributing already in terms of the geometry and the shape of the building. Abator, the engineer who I just spoke about with the circumferential base of the building. He further worked in Dublin, on the US Embassy building in Dublin, where he worked with these sculptural forms for the architect. And he came back to India in the 60s. After having worked there, he came back on a project from there, and this is interesting because we are going to talk about Korea also, that Korea actually, while he was on Pragati Maidan for the agricultural pavilion in Delhi that Yamasaki was doing, Korea sought him out on the site and said, I've heard about you, you must come back to India. I'm coming back to India, we all must be back to practice here. And that left and Korea didn't know him at all. He sort of sought him out, and that was the first time they met, and that was the beginning of a deep friendship they all shared through their life. And what is amazing is the way he constantly stuck his neck out. Korea also mentioned that many times, empowering architects of this country to create structurally expressive forms through decades of practice, despite technological and material limitations. And this is again important, the limitations created inventive use of concrete. Low levels of mechanization and cheaper construction allowed experiments that he exploited to create artifacts that are uniquely indigenous, uniquely in a way Indian, but also remarkably global in nature. The result, as Mark Jasenbeck states, he's a historian of architecture from MIT, that is Raj's astonishing contribution to the world of architectural history in India that has no real parallel anywhere in the world. So today's presentation, we are splitting into two categories. I will take the first part, which is where we speak about the large span structures that he created, which were really more structural buildings that had there were buildings which are really structured with the proportioning that came from architecture. And then we talk about architectural buildings where he sort of, through his innovations, imagine new spaces within that, and that Vandini will be talking about. The first project was the building without plans. It was the Hindustan Lever Pavilion with Charles Correa. Correa came to the office and sort of threw a crumpled paper on Mr. Raj's desk and said, I want a building like this. So Raj said, well, we can't give you a building like this, but if you follow my rules, then we can create a building which is close. And he sort of gave the shape of the triangles he could use and the idea of these triangular plates that come together. And this building was built. And this was a temporary structure. What is interesting is that there were no drawings. Correa made a model and sent it to the office based on which structural drawings were done, which you can see here. With the beginning of what Mr. Raj's practice was about is about these construction notes that he left on every drawing for the contractor, which was highly detailed notes to tell them how to build the building. And between the model and these drawings, this whole building was constructed. So it's actually a very beautiful story in the 60s. During this time in 64, he also, with Correa, did the municipal stadium of Ahmedabad, where Correa very excitedly came to Mr. Raj saying that, the municipal commissioner has given me this project, but he's asked us to do only one bay of the stadium, but he's giving us 50,000 rupees for that, which was a lot of money that time. And Correa said, I'll keep 25, you keep 25, let's build this building together. And they both agreed because it was for people who are just starting out, it was a huge opportunity. And this is the first place he tried his folded plate experience in India, which was a cantilevered folded plate. I'll come back to, these are the options, but it was a cantilevered folded plate, 20-meter span. This is 20 meters, and it's a tapered folded plate which comes down with plate thicknesses of 10 to 15 centimeters, and it's also tied to the seating here. And the whole form is extremely center, and this angle allows the center of gravity to flow down to create a very sort of slim sections with also extremely sort of aesthetic foundations. I don't know, this is the foundation drawing, which shows how beautifully everything was managed, everything was minimized, because it was also a time of where they wanted to minimize the use of material. And the way Mr. Raj practiced, sorry, I'm going to go back and forth in this, is that he came up with lots of options, and these were the many options he came up with, finally which the last one there was chosen. And these are some of the images now. This is the roof, and this joint called the knuckle here, which sort of took the entire force and then translated it here. The images from below. This is the foundation plan. So these were, again, the construction notes that were written for the working of for the pouring of the concrete. And when the concrete was poured, they had to sort of, at some places, lift it, some places, they had to load it down for the whole, the roof to settle into one line and then the edge diaphragm was connected to it. So these were the notes written as part of the drawings. Tagore, at this time, he was also working with Doshi with Tagore Hall. This was another folded plate experiment where he it was a roof wall system that he developed. And inside was the theater, which had its own sort of independent structure with these nervy-like columns. Before we go back to that, this itself has an interesting story where Doshi wasn't happy with any of the columns, the way the columns were coming down. And Raj, who was very influenced by Nervi, wanted to try out how to let the stresses move from the beam to the floor with its logical flow. And he twisted the columns this way, aligning from the beam down to the floor below. And that's how this emerged, this whole form, and it changed the space. And this was set inside a 33-meter span building, sort of a volumetric building, which was a folded plate portal. And what is interesting in this is the fact the way this folds come down, become slender. At this point, they are at the same, the roof and the wall have the same dimension, and then it slims down and expands onto the other side. This is the seating and the column here. This is the reinforcement diagrams of the folds from the outside. These were the different options that he created for Doshi to choose from. These were 6, and then there were more. They're not here. But what is interesting is we just recently did a retrospective of his work in Kiran Nadar, and we sort of created models of all these options. And what we saw was his own thought process also, and how he started with a certain folded wall and roof structure into something which became integrated, and finally led to the final form, which was this integrated folds that came from the roof onto the wall. These are some of the shots of construction there. Today's in time, it is still there as a presence. Hall of Nations is, he came back to Delhi in the 70s, and this is where his practice really picked up in terms of sort of these extremely structurally expressive buildings. And Hall of Nations was one of them, which was a 84-meter by 84-meter large span structure. It was the first of its kind in the world, cast in concrete, in situ space frame structure. There are a lot of engineers when we were trying to save the Hall of Nations. This building is now demolished, and there were a few people who criticized the structure, especially from the engineering, and they said space frame should be in metal. Why was it in concrete? And that's again when we realized the need for people to get more and more educated on these works, because metal in 70s was, steel was extremely expensive material, and actually it was first designed in steel, and then it was designed in precast concrete, and then it was designed in cast in situ, because steel was too expensive for the government to afford. Then the precast concrete the contractor gave up on, and then it was finally done in cast in situ concrete. And this was all done in 2 years' time, and drawings for all 3 alternatives or structures was made. So that also shows the rigor and the discipline of working and the discipline of practice that took every idea to its logical end. And this building actually is a very simple building. It starts with these 3 pyramids below, inverted pyramids, which then sort of replicate, and they sort of create this entire structure spanning 84 meters by 84 meters from the outer edge, from this side to the other side end. And this is the plan, and this is the sort of the diagram which sort of gives the entire information for this construction of from the 3 pyramids below, and how it develops into 4, and then 5, and then it goes on like that. And it sort of creates this whole space frame, which rises up to almost 38 meters. And it was these are the drawings which show the steel, the precast, and the cast in situ concrete. And this was also the place where he innovated this joint in the form, the geometry, what we call the robust rhombus. The delicacy of the structure comes from this geometry, which is a rhomboidal geometry, which just allows the edges to be to be perceived by people, and it really sort of the feel of the building and its and the delicacy that came was because of this joint. And this was all 25 meter by 25 meters. And we, again, for the show, we have created models of this. Unfortunately, we don't have those images today, but we created reinforcement models of this. And the first, even our in-house engineers were like, no, this is three-dimensional. You couldn't have such a complex building in rhomboidal shape. And they must have been square, and he's showing three-dimension. And they insisted on doing a square model of the reinforcement, which looked extremely bulky. And we had to insist, no, it is a rhomboidal shape. And the moment it became a rhomboid, the whole aesthetic changed. It became so light and beautiful that that it was, for us also, it was an actual proof of the genius of intention of suggestions by the engineer that created the building that was actually, it has no parallel in the world even today. These were some of the drawings of the reinforcement of the joints. There were 13-member joints, there were 11-member joints, there were 9-member joints, there were 7-member joints, and each one was a highly complex joint, which took a lot of time, even in today's time, for us to figure out. And this was done in the 70s, on site, in the 2-year period. These are some of the images of construction and some of the calculation sheets. And these, again, another thing is all these buildings were done before the computers came in. They were manual calculators at that point of time. Another important part of his practice was, as we started speaking about in Ahmedabad, was that every building was detailed in terms of also the constructional logic. And for the Hall of Nations, he analyzed all the stages of construction as separate structures. So each and every stage was analyzed as a separate structure to understand when and how the scaffolding can be reduced, because at that point it was important to also remove scaffolding as fast as possible to minimize use of material. And finally, as when the building was, he devised 5 stages of construction, and when the building came up, the building was actually not the way they envisaged the construction. The contractor had gone up in one point and was less in the other, so they had to reanalyze that whole sort of form again to see whether they can remove the scaffolding and the building will stand on its own, and it did, and they continued further. Oops, what happened? These are some of the notes. And this is the building from the outside, was the building from the outside and from the inside. And the magic of the building is really these rhomboidal forms, which sort of create this extremely delicate looking surface, almost like a filigree. Hindon River Mills was another project which was done during this very sort of creative period where he was the main, this was actually his project. He was the main consultant, and then he hired and got in Kanvinde as the architect. And it was a textile mill for DCM, where the first, textile mills typically require small volumes, very low volumes, and large spaces. And first, they wanted this in building as 21 meters by 18 meters spans. So the client first came with the brief of having a low volume building with 21 meters by 18 meters span, but also with the capacity to carry humidified air for the functioning of the textile mill. So these were some of the, it's not working. These were some of the forms that he came up with for that. And then the client changed the brief on him, saying that he wanted, they wanted to double the space up, and they didn't want 21 anymore, but they wanted almost 48 meters. And that's when Mr. Raj proposed this, that instead of then putting a column in the middle, like he did here, he proposed that we span the entire 48 meters with a twin arch structure. And he sort of gave this, and the client wanted to make sure that it's not more expensive. So he created this whole analysis with the moment diagrams, which shows how the structure is actually more economical, not much more expensive, and also uses less steel. So this was the structure, twin arches spanning 48 meters at every 15 meters, and to create this space inside. These were tied, post-tensioned on the edges, and the tie beam became the duct. And this is the drawing of the post-tensioning and the arch. This was again the construction where again there were detailed notes on how the construction has to take place, and these are some of the shots of the construction. This is some Mahata images. And from there we come to his Srinagar Sports Stadium, which was built in the 80s, which took a step. It went further from the Hall of Nations and sort of actually in a very similar aesthetic, but it's actually triangulated plates and not a space frame structure. And this was on the left side is this was done by Kanvinde Rai Chaudhary, and Mr. Raj always says Mr. Kanvinde was one of the most, it was a lot of fun for him to work with Kanvinde because there was this genuine respect. And Mr. Kanvinde was one of the most humble architects who would accept everything that an engineer or anyone else would give him, and as long as it was in the interest of the building. And this was the original plan, which had pylons in the middle, and it was a cross-shaped plan. So keeping the intent of the cross-shaped plan, Mr. Raj suggested a totally different aesthetic of these triangular plates, which sort of, there was a set of seven plates on each side, which created this cross-shaped plan, but also gave, it's not working, gave a clean span of 74 meters inside. Mr. Kanvinde accepted it, but it was a radically different aesthetic that emerged. This is the drawing of that, which shows the intent of the building with the cross-shaped plan, the 7 plates coming together as a fold and coming onto the roof as a steel system. These were some other drawings done, and this shows the normal view, which shows the original, the authentic view of what the dimension of the plate fold would, I mean the luggage joint would be on site. And this was the foundation plan, where again we love showing this foundation plan because it shows that at no level was the aesthetic of the structure, the art of structure, where the aesthetic of the foundation is also beyond the geometry, the triangulation, the slimness of the, and this is all under the ground, no one can see it, but the rigor of dematerializing structure was so intense that it went right from below the ground to the roof. This was the seating which was integrated to the folds. And these were the organic shaped forms that emerged because they were post-tension sort of horizontal members that were holding these plates together, and where they came on the diagonal, these forms were created. And this again was intensely worked between the model maker in Kanvinde's office and Mr. Raj. They used to work, and then these drawings were done in the office based on the models done in Kanvinde's. This is, those are the pre-tensioned forms which were shown earlier along the 4 edges of the building. Again, this was one of the construction notes that were given so that where the scaffolding can come down and how and when the building itself becomes self-supporting. These are some other shots. This is as it is, this was after the flood in Kashmir. And I'll now ask Vandini to come in.
Good morning, everyone. I'll continue by showing buildings of Mr. Raj, which were not so overtly about the structural gymnastics or, very large spans, or which he, had the primary say as a structural consultant, but more buildings with innovations and inventiveness to bring out the demands and the desires of the architects. Solutions that help realize and even enhance the imaginations of what the architects were suggesting. In these buildings, the design of the structural system and elements, as also of the processes and techniques of construction, give a new dimension and spans of spatial possibilities, whether it be through cleaning up dozens of columns, creating clear open spaces, or lifting off the spaces by transferring loads elsewhere, or just even tapering and shaping the elements. So we'll go back. I'm going to run through that. I think we don't have that much time left, but this is one of his first projects when he came back to Bombay and started his practice in the 60s, the new great insurance building. It's a building that was, the demand of the client was to build a 6-story office building on top of a 3-story garage. So this is the existing building below that you see, on top of which the construction goes up. So he decided that, he shouldn't really, that they didn't have the existing drawings of the garage structure, obviously, and so to build on top of a 6-story building on top of this garage without the structural knowledge of the columns and the slabs, etc. So they decided to puncture, Mr. Raj decided to puncture through the slabs of the existing building and create a few columns which opened up like forks like this, and which lifted the building, the 6-story office building, above the structure. So here again, this is a Sri Ram Center, which was also done in the early 60s. It's the Sri Ram Center of Art and Culture in Delhi. Here, architect Shivnath Prasad had a very, we all know about his love for Corbusier's work and what a great follower of his style that he was. But despite sort of a very clear architectural language, in this building, Mr. Raj was able to suggest very dramatic structural solutions which enhanced the building further. So like we see here, one of the most interesting effects of this building is this drum-like base of which this parasol kind of structure almost seems floating above. And so that is coming from a structural separation of these two volumes, which was not part of the original design, but because of the way it was designed as a drum shape below. And this 31 meters by 31 meter parasol structure that was lifted up on just 4 columns, as you may see, which are holding up this parasol structure, these cross-shaped columns. Then is, so these are the cross-shaped columns, and then they take the weight of the parasol, form above. Through these, again, so the details of these elements really matter, the way every element and form is tapered to the absolute precise requirement of that structural element. So that's the drum below and the parasol on the left. And as Rohit mentioned, the notes in his drawings are really the key. So one of the things we really learned over the last, I think, decade that we've been doing studying his work, and we came up with his book and several presentations and exhibitions, we realized how much, and every time we learn more, because as much as we stared at those drawings and calculation sheets and notes that he created, it's amazing how much information was parted through those notes. And every detail and precision was really part of very concisely, I mean, they were elaborate and very large number of drawings. So the joke between Mr. Raj and his wife was that she always said for every drawing that an architect makes, Mr. Raj would make 10. So each project had a huge volume of drawings, which were really beautifully composed. I mean, there's no blank spaces, there's no empty, there's no, they were handmade drawings. So despite the effort of remaking drawings, they were very, very precisely composed. And then the notes were just loaded, thanks, with information for the design, for the contractor to build, etc. This is the current. So then in 1969, this is the Akbar Hotel The main hotel block, this is also a Shivnath Prasad building. And in his original drawings, when he came to Mr. Raj, he had, the main entry foyer was full of columns because this is a hotel. It was a hotel, and so the requirements of hotels required columns through the building. But Mr. Raj said that he was not really happy with the foyer being full of columns. So he said, we're going to get rid of all of them, which he did. And he created this, I think we believe, and this could be wrong, but we believe that this was the first time a foyer in a hotel was cleaned out and made without any columns. And he created this transitional floor just above the foyer, which is a full floor, and that also takes the services, but it also uses it as a transfer floor for all the columns above into transfer columns and girders that, freed up the lobby space. So, as you can see in the section, the 9-story building above of the hotel uses all the columns, and then it comes to this 2 transitional floors. Actually, you can see the transitional floors, and then the 2 floors of the lobby and the public spaces. So that was not it. Of course, after opening up these floors, he also, Shivnath Prasad had a very clear idea of how he wanted the building to not have a very, the foyer to have a very slender, just a slender beam. So, of course, the building is coming down 9 floors high, and how are we going to make this slender beam? So, Mr. Raj suggested this webbed rib, structure for the slab of the foyer, which actually became like an ornament for the foyer itself, because here he webbed the ribs in such a way that they became deeper in the center and became slimmer at the edges, so that the beam on the periphery of the building was the dimension that Mr. Shivnath Prasad required. And he pulled out the columns. I mean, that was part of the architectural statement. But then he collected them around collected the web around the columns, as you can see. So this is This drawing really, I mean, I always have to stare at it for a while because it just feels like the reinforcement is talking to you and it's dancing. And so this is, you can see in the column in the beam section how it's ribbed and how the center is actually deeper. And as it goes to the column, it becomes so slender so that the peripheral beam became the dimension that he required, which I think was just about a foot high. Am I right? And this is that transfer girder. The transfer girder that was in the transitional floor. And of course, all of these he uses very extensively, as Rohit also mentioned, pre-stressing as a technique, which in those days I think was not very prevalent. And I'm talking to a group of very eminent engineers, so we'd love to have more discussions or questions about how, because Mr. Raj, actually, I've questioned him on this so many times, that was this really unique? Because he uses pre-stressed concrete so easily, and he talks about it with so much ease, saying, yeah, it happens all the time. I said, really? But in that time, in the 60s, was it so common when concrete and steel was barely available, and you had to collect the material before you even started construction, etc. So this is still a mystery. I don't know whether it's his humility or it was just his ease of construction and imagining buildings and structures. And then again the sequence, notes, stages of construction, really an important part of his work. It was not just the building and the final product, but that process that mattered so much to him. So he could bring the efficiency out, he could bring the efficiency of time, the materials, and of the most efficient structure required. And this is that beautiful web ceiling and no columns in the foyer, which is a beautiful shot by the Mahatas again. This is the central bank done with architect B.V. Doshi. And again, this was a building in the 60s, 69. It's a 6-story office tower again on a podium which is irregular shape. And here he uses these 4-column bays to lift the whole building above the podium level, creating very large openings below. So this is, the lifted space, and you create really large openings. And there are just the corners are 4-column bays, which have 2 large transfer girders across, and the whole building is lifted off them. And these sun breakers are placed on thin transfer grids, which span the columns in 2 directions. So that structural clarity and refinement that he could bring to very clear ideas of the architects is what, my part of this presentation is showing. This is the transfer girder and the slab and all the reinforcement and the detailing in that. This is the podium level where he lifted off the whole building and he suspended, there was a suspended floor. This is the Premabai Hall, also in Ahmedabad with B.V. Doshi. And here, 2 exposed concrete shear walls, which are parallel shear walls, are the main structural system of this building. And then the end, as you can see, is this cantilevered end, which gives it sort of this dinosauric kind of a form. The roof of the main hall is 55 meters by 37 meters, and a seating capacity of 1,000. And again, here he's using 4 shaft columns connected with deep concrete reinforced girders. And the seating bowl is held together by wall-like girders. So these are 21 meter deep girders, which are almost like walls, a whole 2 stories high, which are holding the entire seating frame up. This is to mention, he was a structural advisor in this IIM Ahmedabad building. He was not the main structural designer, but he had very important inputs, and we just wanted to bring this out, where, brick was used as the main element, and he was not very happy. He was like, this is a small element, you want large spans in this building, so how are we going to use brick, which is not really a structure to make large spans? So the concrete tie was his recommendation in this form, which we believe lent a great deal to the refinement of these ideas that the architects had very clear visions of. So, this concrete tie that you see, which is holding the arch, gives it that stability and an elegance. This is in the 80s, this is the NCDC building by Kuldeep Singh in Delhi. And here, this was, again, a very clear idea that Kuldeep Singh had of this sort of zigzagging building shape that was, ascending up. And it's known in Delhi as the Fata Pajama building, but, that's what it looks like. And these shifting load transfers, so again, the friendship and the association he had with most of his architect friends was quite amazing. So Kuldeep Singh had done this design, and this was a competition. And in the jury, when he presented this design, the jurors said this building is not possible because it won't stand. So he's saying, don't worry, Mr. Mahendra Raj is going to be my structural designer. So they said, okay, you call him in. And then, of course, once Mr. Raj could convince them, and then that's how he won the design, and they built it pretty much how he had designed it again. So again, to say that he was also a great, architects could imagine, because of their friendship, things that were not always possible and easy to imagine as forms. And so here again, these 2 shear walls on the side and these meandering columns hold the whole building together through the corridor. So the corridor becomes a very important part of holding this meandering form. And the corridor goes through from one end of the building to the other end, either as a strut or as a tie. So either it's holding in tension or in compression the entire meandering form together, and which becomes a corridor. So it's a functional element as well. And it's post-tensioned. At the ends, you can see in the center of the building, you can see these little brackets or blocks which have post-tension members in them. I'll just go back and stay for a minute with these calculation sheets that you see on your right-hand side. And so all of these are hand-done calculations. There are reams of these calculations we have, and now we are beginning to analyze them further, and this is the next stage of the work that we're going to be doing on his archives. Because all of these are also, such beautiful art relics. They look so beautiful, and structurally they became the methods by which he could imagine and calculate these very complex structures. And as Rohit showed earlier, he didn't leave any stone unturned. So there were various options. So what was the best possibility was imagined and drawn out in these calculations through these diagrams and very detailed mathematical equations for all the different combinations. So he says that unless you do the calculation, you can't imagine what the possibility of that structure is. So each of those different combinations and suggestions and options he came up with had detailed, even if they weren't finally used, they had detailed calculation sheets attached to them. And these are just so beautiful. I mean, you just can see the calculation sheets showing all of the drama of the building, the tensions. You can feel the tension and the forces and moments of the building. So here are, again, stages of construction, an important part of his work, and very simplified and clear for contractors to understand. These are the different floors where it's either a strut or the central corridor which holds the whole building together. And these are the meandering columns and the shear walls. Then I'll just sort of wrap up with this. I think I'm overshot time. How am I doing with time? Should I skip this? Okay, this is the Vidhan Bhavan with architect Charles Correa. And this is by the 90s. Here already structural geometry was not that important, and it was more about, architectural forms and ideologies, where the structure was not such an expressive part. But Mr. Raj doesn't stop exploring, even today, as he's 95, and nor did he in this building. As we all know, these forms don't stand out at us, but there are these, this is the multi-purpose hall, which is a doubly curved shell roof, which is 43 meters by 43 meters. This is a 31-meter diameter, the main Vidhan Sabha hall, which is a concrete dome, hemispherical dome, which is, the thickness is only between 10 to 20 centimeters, tapering. And all the drawings done for that. This is the Vidhan Parishad roof, which is a composite structure. Oh, sorry, I'm so sorry. This is the shell. This is the double curved shell of the multi-purpose hall. And these are the columns at the many foyers that were at the Vidhan Sabha, which are 30-meter by 30-meter spaces supported on just 4 columns, which are these. So as Nervi said, the pattern of steel should always have an aesthetic quality and give the impression of being a nervous system capable of bringing life to a dead mass of concrete. And we see Mr. Raj's drawings really show this so beautifully. So I'll just wrap up by saying that the body of work of Mr. Raj really showcases the nuances of engineering and design and explorations in concrete as a new material to its possible limits, but also defying technological and material limitations within the country at that time. Almost all these projects shown in that era would also now be called modern heritage, which we're hoping that this, the word modern heritage gains more prominence in everyday language so that, we don't lose many more buildings like the Hall of Nations. I want to sum up by saying that the innovation in process and technique of Mr. Raj's work really marks a crucial time in history. The structural drawings of his projects are historic documents and hold the key to many hidden processes and secrets of the structures he created. In addition of being pieces of art, they are also packed with information and instructions and indefinite details, revealing how tightly he controlled the building process as part of his design. And again, to quote Mark Jassenberg, his gift was to bring to every project the magic of engineering. And I'd like to just stop with that, just to think about, this magical world that he could create with such a functional, practical, and precise method of engineering. I think that's what we want to celebrate. And we really want to thank Aesa for inviting Mr. Raj. With his message, he was very glad that there's an association which is so long-standing, which is bringing together engineers and architects and other disciplines and surveyors. And so I think this is something I hope can multiply in forms all over the world, because I think this is required so that it doesn't become only about the masters of architecture, but about the team that built the buildings, everyone to their due credit. Thank you so much, everyone.
Thank you, Vandini and Rohit.